Hello, today's lesson is on multiplying decimals. It's 2.5 in your Big Ideas Math textbook. So when we're looking at multiplying decimals, we want to talk about what multiplying means, right? Different ways to express multiplication. So when you have a number next to parentheses, that means times. You're very familiar with an X, that means times. We can get rid of the X or the dot altogether and just smash a number next to a variable, and that means to multiply, or it means three groups of n, right? That's how we multiply. Or two parentheses next to each other, that means to multiply. You could use a dot. You could even use an asterisk. So the meaning of multiplication either looks like three groups of five or five groups of three, right? This is called an array when you make groups like this. And then this is the area model where we have a square that's 3 by 5, which means we have 15 squares altogether. Okay, so some quick instructions on rounding. The idea is rounding is very useful for estimating, right? And as it says here, that multiplying and dividing decimals can get confusing. So if you make an estimate, you have something to use to check your answer. And we can do easy estimation, right? We don't want to make it complicated. We're just going to usually round to the next biggest place value. And what I memorized was if it's 5 or more, let it soar. 4 or less, let it rest. Okay, so there's not a right or wrong answer when we are estimating, right? So let's go ahead and look at, so here's, I guess, let's see, I'll move it over here. We'll do the A and B first. Okay, so if I'm trying to estimate the product of 23 times 50, because these numbers are in the tens, right? Why don't I just round up to the 10th? So I'm going to look at the 6. It's 5 or more, so I round that up to 60. And this is less than 5, so I keep it as it is. So I can really say that this is 20 times 60. And then remember the easy thing when you're multiplying by powers of 0, I just do 2 times 6 is 12, and then I add the 2 zeros. So I got 1200 for my estimate. Okay, so now I have 110 times 55. Now I could leave this and round to the 110s, but why don't I just round to the hundreds? So I underline this number. If it's 4 or less, let it rest. So that means the 1 stays. So this is 100. This is 5 or more, let it soar. So I bump up the 6, the 5, sorry. I bump up the 5 to a 6, and it's 100 times 60 equals 1 times 6 is 6, and I have 1, 2, 3 zeros. So it's about 6,000. Okay, let's look at a couple more examples. Here is C and D. Oh yeah, and then I'll show you the hill. Okay, so I'm going to say this is 4 or less, let it rest. So I just round that to 4. And then this is 5 or more, so I bump it up to 8. 4 times 8 is 32. And then for D, I think I'm going to make my life easy. I don't even want to use 1.2. I could underline the 5 and bump that up. That's kind of an ugly number to work with, right? Notice how I have all whole numbers, no decimals in my estimating. So let's skip that and just say there's something called front-end estimation, and it's so cool. I can just take the decimals and cut it off and just call that a 1. I could do the same thing with this one, or I could bump it up, but I'm going to use front-end estimation and ignore the decimals. So I get 1 times 8 equals 8. Maybe you did 9 as your estimate, but that's okay too. All right, so this one has a decimal. I'm going to go ahead and say if it's 4 or less, let it rest. That is 2 is less than 4. So this 4 stays, and I have 4 times. Now this one's also kind of interesting. I could underline the 2 and estimate it as 0.9, but I don't want to do that, right? I like multiplying by whole numbers. So I'm going to underline the 9. The 9 is more than 5, so it's going to bump up the next higher place value, which becomes the 0 becomes a 1. So I get 4 as my estimate. Okay, for this one, let's see, I'm going to do front-end estimation on that. I have 1 times. This is one of those ones where if I bump this down to 0, that's not super helpful. So I think for this one, I'm going to have a decimal in my answer. Underline the 5. It's 5 or more, let it soar. So that means the 0.2 rounds up to 0.3. But hopefully you know that if you have 1 times 0.3, it just equals 0.3. Okay, so I have this little graphic down here that I basically just want to show you. It's kind of like you're going up a hill with a number, and once you get to 5, you keep going over the other side. If you are less than 5, that means you're not even to the middle point of the hill, and you might as well roll back down to the original number. Okay, so now let's look at this activity that I'm having you do so that you can start to understand what it means when you multiply decimals. So I want you to first use estimation to see what a reasonable answer would be to this, right? 7.3 times 2.5. So I'm going to say that this is close to 7 and this is close to 3. So here's my estimation. 7 times 3 equals 21, right? So that's my estimate. Now the second step says multiply the numbers as if they did not have any decimals. So really, this is what I want to do because this is the multiplication problem I'm supposed to do. I'm supposed to figure out what 7.3 times 2.5 is. But over here is where I'm going to do this second step. I'm going to multiply as if there were no decimals. So 5 times 3 is 15. Regroup the 1. 35 plus 1 is 36. Now when I start to multiply the 2, this is in the tens place, so I have to put a 0 because that 2 stands for 20. 2 times 3 is 6, and 2 times 7 is 14. Okay, when I add these numbers together, I get 1,825. Ooh, but wait a minute. I said my estimate was supposed to be around 21. So here's what I'm going to say. It says locate the decimal place by comparing your answer with your estimation to see what is reasonable. Oops, the reasonable part is cut off down there. Okay, now you can kind of see the word. So here's what I'm thinking. I'm thinking my estimate was 21, and if I put the decimal here, then that's close to the estimate. So I'm just making a little note that says 18.25 is close to 21. That's how I know that the product is 18.25. Okay, let's keep going. Now you're going to do some OYOs. So I've got 4 multiplication problems to do, but remember what I want you to do. Well, I'll show you on the first one. You're going to estimate and then give the actual answer. So when I take this 73, I underline the 3. If it's 5 or more, let it soar, but if it's 4 or less, let it rest. So the 7 stays a 7. So my estimate is 70 times. This is going to bump the 2 up to a 3, so I have 70 times 3, 210 is my estimate. Now when I do my actual multiplying, I kind of already know what the answer is going to be, right? 73 times 25. I'm going to get the same thing. Well, I'll see. Let's see. 7 times 3, 3 times 5, 15, 36. So you're going to notice that I'm going to get the same total answer that I did on the first problem. Okay, so the actual number, every time I multiply 73 times 25, I know it's going to be 1825. And now what I want to do is I want to look at my estimate and I want to figure out where the decimal goes. That makes sense, right? Is 200 close to 1,000 if I put the decimal there? No. But is it close to 182.5? Yes. So that's where my decimal goes because 182.5 is close to 210. And now I'm just going to set up these other problems. Okay, so for number 2, here's my estimate. It gets bumped up to 1 times 25 equals 25. When I do the multiplying, I don't even need to write that down again, right? I can just put my total, even though you wouldn't do that on a test, but this is the same 2 numbers that I'm multiplying, so I know I'm going to get 1825 as my answer every time. But now I want, my estimate was 25. So wherever I put the decimal, it has to be a number that's close to 25. So it makes sense to move my decimal all the way here and say that 18.25 is my answer because it is close is close to 25. Okay, so we're going to look for patterns and then we're done with this. All right, so my estimation for number 3, I'm going to round the 7.3. It stays the same, right? It don't bump it up. I get 7 times, let's take this 5 and bump up the 2 to 30. So I have a nice round number to multiply. I get 210 as my estimate. And then I notice when I multiply 73 times 25, you know I'm going to get 1825. So sort of similar to this one where the estimate was 210, it makes sense that the answer is 182.5. So I say 182.5, that's my answer, and it is close to 210. All right, let's look at the last one. Oh, this is a little bit different, right? This is a smaller number. This has a decimal. The first numbers are the same, but the second numbers are a little different. So I'm going to round up the 7. And the ones place. I look at the tenths place and I bump that up to 1. And then I think I'm going to bump the 5, right? 5 or more. The whole number is going to bump up. So I get 1 times 3 equals 3. So there's my estimate. And then when I multiply 73 times 25, I know I'm going to get 1825. And where does it make sense to put the decimal if my answer is supposed to be close to 3? Well, the only place that makes sense is right here at the 1.825. Okay, I can do this. There it is. And that is close to 3. Right? It's not exactly 3, but it's close. Okay, so now we just did some multiplying, pretending there were no decimals and trying to figure out where the decimal would go and what makes sense based on my estimate. So now, let's start looking at some things that you might notice, right? So what I start noticing is the digits 1825 are the same. And so you might want to start by counting the decimals in the multiplication problem and see if you can find a connection. So I'm going to pause that for a minute. You're looking for patterns and connections. Okay, so I'm just going to point out this, right? So the digits are the same in the factors, right? The factors are 73 and 25. This is still 73 and 25. I just put in a decimal point, right? And a placeholder 0. And so the idea is that you are going to multiply. You're going to multiply as if there are no decimals. And then we're going to put the decimals back in by counting the digits after the decimal in both factors. So notice there's 1, 2 decimal places, which is why there's 2 decimal places in the product. Here, there's only 1 decimal place, only 1 number after the decimal, which is why there's only 1 in the product. There's 2 in the factor, and there's 2 in the product. 1 and 1. Now, the other thing we want to notice is this. When you multiply a number by a number less than 1, the product is smaller than the number. So, for instance, I'm going to take, and I'm going to look at C. And I'm going to say, what happens when I take 25 and I multiply by a number less than 1? The number is less than 25. When I take 25 and I multiply by a number that's greater than 1, then I get something that's bigger than 25. It's another pattern that you might have seen or you might have noticed. Okay, so now let's finalize this and just add a few notes to our notes page. So when you're multiplying decimals, you count the decimal places in the factors, right? And I wanted to let you know that it's both factors, right? You have to look at both numbers that you're multiplying. We only ever multiply 2 numbers at a time. That's how I can use the word both. And then you put the same number of places behind the decimal in the product. And sometimes it's not a bad idea to write on the side, if you see 2 decimal places and 1 decimal places, and you add them up to 3 decimal places. Okay, so now let's practice a little OYO. Here's 2 problems. Go ahead and pause the video, and then I'll show you how to do these 2 problems. Okay, I'm writing 1.785. Notice this. I am not lining up the decimals. We pretending there are no decimals, and then we're going to put the decimals back. All right, 5 times 4 is 20. Regroup the 2. 4 times 8 is 32. 34. Regroup the 3. 4 times 7 is 28. 31. Regroup the 3. 4 times 1 is 4, plus 3 is 7. Now I have 1, 2, 3 places, right? 3 decimal places. I have 1 decimal place. When I add those together, I get a total of 4 decimal places. I'm counting 1, 2, 3, 4. I put the decimal. I also want to put a leading 0, and I rewrite my answer, and I put a box around it. That is a very small number. I took a number that was a little bit bigger than 1, and I multiplied by half, so that seems reasonable. Okay, I'm going to estimate this one. I think I'll use front-end estimation, and I'll just do 2 times 9. I know my estimate is going to be around 18. Okay, now, I usually, when I'm going to call it long multiplication. When I'm doing long multiplication like this, the number with more digits usually goes on top. It's not wrong to do it the other way. It's just easier to multiply the 7 times everything and the 2 times everything rather than having the 9 on the bottom and having to multiply 3 different digits. All right, 7 times 4 is 28. Regroup the 2. 7 times 0 is 0, plus 2. 7 times 9 is 63. I put a 0. Even though this number is actually a 2, it's still representing the tens place because I'm pretending there are no decimals. So this would be 2 times 4 is 8, 2 times 0, and 2 times 9 is 18. When I add up all those numbers, I get 8, 10, 4, 14. Okay, now I have 1, 2 decimal places, 1 decimal place, which means my final product has to have 3 decimal places. 1, 2, 3, that's where the decimal goes, 24.408. I go back and I look at my estimate. Is 24 close to 18? Yes, it is. Okay, that's it for today's lesson.